Hello, welcome to this presentation on using advanced steel for material handling. So my name is Alec Giles. I'm a structures consultant at Greytech UK, and I'm also an Autodesk Expert Elite. I originally trained as a mechanical design engineer around 30 years ago and was a member of the IED. I spent about 10 years designing machinery, and then I moved sideways to become the CAD manager for the company I was at, looking after around 200 users of AutoCAD and Inventor and Solid Edge. I came to Greytech in February 2010, so I've been here now for 11 and a half years, and I've been focusing 100% of that time, providing user support, training, sales demos, consultancy, and so on. So overall, I have around 20 years experience in support and consultancy. Why should you choose Greytech as your partner in business? Well, we believe we're unique in being able to offer services and products across the entire life cycle of your own products. And we like to split that into 4 categories. First of all, we have Create, where you can use Autodesk's software to design your products, and that software is enhanced with Greytech Power Packs, which add extra functionality and productivity tools to them. Once you've got your basic design, you need to test it to see if it's going to work in the real world, so you can use Greytech Simulate, where we have state-of-the-art software available there to do all the analysis on your designs to make sure they really are going to work in real life. Once you finalize your design, you need to manufacture it, so then we move into Greytech Fabricate, and we have tools and services there which can help you manage your entire workshop. And that's everything from managing your people, like the welder or the man cutting the miter saw, all the way through to sending the right NC files to the right NC machinery and scheduling and everything else for your workshop. And then finally, all of that work creates an awful lot of data and a lot of files. So we have Greytech Manage, where we have the OpenTree software that can control all of your work in progress data, everything going through your company, make sure everybody's working on the latest version, the correct versions, track changes, and so on, all the way up to when you put it into an external common data environment. So we can support you and work with you throughout the entire life cycles of your projects. This webinar is one of many that we do, so if you've missed any in the past, please make a note of the link at the top left there. You can have a list on that page there of all the previous webinars we've done. There's well over 50 there now, so you've got plenty of on-demand training that you can look at free of charge. Just go back and review any of our previous webinars. They're all full of tips and tricks or demonstrations of how the software can cope with various things. Okay, so moving on to today's webinar. We're going to look at some structures and things for the materials handling industry. So we're going to model that image on the right. So you can see there you've got some basic structure supporting a conveyor belt on a slope. You've got a hopper at the top of that, so it's going to lift rubble, shall we say, up the slope, drop it through the hopper into the back of the dumper truck. And we've got an access platform and a ladder going up to that platform and some basic railing. So these are the kind of things we're going to model today, and sort of typical stuff you would see in many materials handling facilities, cement works and so on. The demonstration I'm going to do is going to be real time. Nothing's been edited out. I haven't chopped it off and trimmed off a 5-minute wait to make it look like 3 seconds. Everything's happening in real time. If I make a mistake, it's real, it's there, you see the mistakes I make and when I go and correct it. So you can really see how long it genuinely takes to model this. During the modeling, I'm going to use all sorts of different techniques. So I'm going to show you a wide range of the advanced steel functionality. Obviously can't show you everything, but I'm going to cover a good proportion of it. So I'm going to include drawing and positioning beams one by one. I'll give you some tips for getting some awkward placements in certain positions. It's not obvious how to get it in the right place, but I'll use some various tricks and tips for that. I'm going to use and create the many joints between the beams. You can see your base plates and bracings and various things. So I'll create all of those and show you how easy all that is. I'm going to use macros to create the bracings. I'm going to use macro to create the ladder and the railings and so on. So again, large chunks of complicated but predictable geometry we can create very quickly. doing this whole model in its entirety is going to take around 50 minutes, give or take a couple of minutes. So I'm not going to go into a lot of depth about creating the drawings today. If you want to see more about creating drawings and things, we've got plenty of other presentations that include more information on how to do that. But I will show you a quick overview of the kind of drawings you get at the end after I finish the model. So you'll see a little bit, but I just won't go into it in depth. Okay then, so let's get ready for the actual demonstration. Okay, so this is the model that we're going to be aiming at to create. We've got the dump truck and we've got a conveyor belt taking materials, rubble or whatever, up to the top, dropping it through a hopper into the back of the dumper truck. Then we've got an access ladder to get to the top if you need to sweep down the hopper. Or do anything else. So fairly simple, but gives you the gist of how materials handling would work. You've got the hoppers, you've got the conveyor belts, you've got the access platforms and so on. Okay, so that's what we're aiming at. Let's close that file. Now, obviously to get there I'm going to have to create things in the right places. I'm going to have to work out some dimensions, and I'm going to have to work out some sizes. There's nothing interesting for you to watch while I'm playing with positions or working out dimensions. So I've done all that in advance. You can see I've already tested the model, and I've created some construction lines for where I want to put things. So there's nothing interesting there. I'm not trying to use any smoke and mirrors. It just saves having to bore you with me experimenting with different positions. So here's my starting point. I've got the dumper truck in place. I've got my origin over here. I'm just going to do a save as there. And away we go. So I've got the construction lines in place. Let's turn those on. Like so. So here we go. We're going to have the hopper here. These shapes here for where the hopper goes. And we're going to have this conveyor belt coming up here to drop things, rubble, into that hopper. Then we need a platform with some legs in these positions. All good. So the first thing I'm going to do is draw most of the conveyor belt. So I'm going to need to draw the sloping beams first of all. So let's get my UCS on the slope. So I'm just going to use UCS at 3 points because it's construction lines. Can't snap to an object. And I'm going to go to the end point there, end point there. That gets my X correct. And then anything else on the plane. So end point there. Okay, that's got Y pointing down. I'd like Y to be pointing up, so let's rotate. Like so. Great. I can draw the sloping support beam. That's going to be a big bit of channel, so I'll go straight for channel. I'll draw it from the bottom to the top. There because I've got my UCS all the way around. I'm going to put that on the corner, and I want that to be a nice big bit of channel, so I'm going to go for something hefty. I'm going to go for 300 by 100. Now, one quirk with channels, if I put the positioning to top middle, because I want that in the middle of the flange, it doesn't go in the middle of the flange, it goes above the centre of gravity. A bit annoying that. So I can't use that top middle position. So although I normally say never ever put a value in the Y or Z, what I'm actually going to do is put it onto the corner and then put a value in Y of -50, and that moves it to the middle of the flange accurately. Let's get my UCS the right way up. Okay. Now that's the centre line. So we'll need to move that out in a minute. I don't know how far it's moving out yet, so let's put in my rollers. So I've got blocks already prepared for the rollers. I've nabbed them from some mechanical equipment manufacturer or supplier. So I'm going to use special parts. So here we go. Special part. I'm going to go for the top of the construction line, and I'm going to insert or browse to my block I want. And there you go. Let's put the block in there. I'll put another one at the bottom. Same block, like so. And then I want to put in the intermediate rollers. They're going to be slightly different because I want the belt to create a trough shape. So I'm going to put it at the top again because that's the only reference point I've got. And I'm going to use the conveyor rollers. And I'm going to move that. I don't want it at the top, obviously on top of the other roll. So I'm just going to do an ordinary move. And I'm going to grab that and move it down 1200. So I'm going to put one at the bottom. And I'm going to move that one up 1200, like so. So that's got either end. Now I want 10 sets of those rollers. I've got 2. I need to divide the space between them equally. So what I'm going to do is just draw an ordinary construction line, temporary. I'll go from a nice easy snap point. So if I go there, I'll get the corner of the roller, or the quadrant on the corner, and I'll go to an end point there. So that's the distance between them. I can use the ordinary AutoCAD divide command to divide that length. And I need to divide it. If I want 10 rollers, want to add another 8 in the middle, I need 9 segments on that bit of line. And that puts AutoCAD points along that line. So I need to change the point to something I can see. Let's change the nice big symbol there. There you go, I can see the points. So now I can copy those those blocks, just use Advanced Steel Copy to all those different points. So I'm going to go from the end point of that. I think I missed. Let's try that again. Copy that from end point to there. Marvellous. So now I can select those points, don't need them anymore. And get rid of that line as well. So I don't know what the gap is, but I know they're equally spaced. Now that beam needs to move out. So I can just do a move from there to there. Needs to be a bit longer to accommodate the fixings there. So I'll move around. Can I get the grip to come up? No, let's go to wireframe then. There's the grip, and I'll extend it 300. And the bottom I'll extend a bit as well. That's better. Now there's no point in drawing in the other side. I'll make everything on this side and I'll mirror it later. So far so good. I'll bolt those rollers to the beam. So that's straightforward. I just need to check my UCS in the right position, yeah. So I can use the bolt group. I'm just going to put in one bolt at a time. So I'm going to go for a rectangular corner point. It's the easiest way. Choose the parts to bolt together. And I've put a node inside the block. What I've done, I've put an AutoCAD point inside the block at the relevant position. That's useful to me. And then I can snap to that AutoCAD point using the node snap. So I've got a node in the middle of that bolt hole, got a node in the middle of that bolt hole, and I've got one on the center line of the roller. So I'm going to use this node here. I just want one bolt each way, and it's going to be a chunky one. It's going to be an M24. And I will simply copy that bolt from there to there and confirm it's that block. And then I can copy a pair of bolts, center like that, all the way up to the center line there. And there you go. Similar for the intermediate rollers. So I'm just going to do a rectangular pattern between the roller and the channel. It's going to be there, and this time it's going to be M16. I'm going to copy that. From there to there. And then I'm going to copy the pair. I'll use the bottom one as the reference. There. Click. There. Click. A good 2 patterns, but like I said, I don't really know what the spacing is, so this way I'm going to work out and worry about any of that. It's not umpteen rollers, it's quick enough to do in one up time like that. So that's got all the bolts in. Fabulous. So we've got half the conveyor belt in. I'm going to go back to the world coordinates now. And it's time to start putting some support structure in. Let's reduce all those points so we don't see them all the time. So type in the command P-type. I can put the points back to being just a dot. Okay, and that hides all those different points. It's nicer, tidier. So I'm going to put in, like I say, some legs and support for that conveyor. So it's another leg here out of channel from the end there. I don't know what the exact height is I want to go. So how do I get it down to 0 level? Well, the easy way to do that is I can use the Z, because it's the Z direction I want to go in. So I can say dot Z. So I'm only going in the Z direction, and then I can snap to the end point on the end of my line on the ground. And then I check all the items like positioning and so on to make sure that's in the right place. So that one's done. I need one in the middle of that conveyor. So I'm going to do the same again. I'm going to snap to midpoint. Make sure it's the middle of the system line. Yep. And again, I can say dot Z onto the end point of my floor line. And it goes down to the floor. And again, double check the positioning. So this time I want it in the middle. It always doesn't remember these values, so I type them in each time. That's fine. Okay, marvellous. Now, I've got to put some joints on them. So I'll go to connection bolt. It's very easy to do the base. That's going to be a base plate. Don't worry about concrete. I'll have a 400 square by 20 thick, and that's in the library. So I'll just go to the library. 400 square, 20 thick. 300 channel, so 400 square for the base plate's reasonable. That's fine, but that's off center. So we need to get that centered. Now the default center position that it's choosing is the center of the web of the channel. Or the center of the web or whatever beam you put it on, not the back of the channel. So I can't just move it across by 50 because that will move it the incorrect amount. It's going to still be off center. I need to know what the web thickness of the channel is, so I can double click on the channel, go to properties, and it tells me in here S web thickness is 9. So that gives me 4.5 is half that web thickness. I would move it 50, but it's already across by 4.5. So 50 minus 4.5 is 45.5. So I need to move that by 45.5. So I'm going to go back into the joint, and on the dimensions page I can offset it, so I'm trying that one, 45.5. Okay, so it's gone the wrong direction, so it's not that one, 0 back in there, try the next one, 45.5. That's it. Okay, so that's parallel to flange. Now bizarrely the bolts always seem to be the opposite one, so I'll try bolts parallel to web. There's an offset there, so I'll try 45.5 there. That's good, that's gone the right way. So now it's in the centre, I can now do a joint copy on that one, to put it on this leg, and it stays in the centre on that leg. At the top, then we can use a nice joint called the gable wall end plate. You've got a preview here, it puts a plate underneath the cross beam on the end of the column. So that's what I want. So let's pick the beams, and in it goes. Not quite set up right, so what I actually need, I only want one row of bolts. No, by the way, one there. I want 3 actually in that direction, and I'll change the spacing to more like 90. That looks better. This collar beam will be extended in a second, so that's decent spacing. I want to make sure the plate matches the size of the channel. So projection 0 all round, so it's going up to the edge of the channel. That's cool. To get this channel right, I just need to do a cut object to make it reach the back of here. I don't know what to add or how to do it, but if I do cut object, I want to cut to the leg and I want to trim that channel. But I don't want to trim to this side, so I change the cut says to the rear, and now it extends to there. This joint is fine, so I can do a joint copy again. Get the right piece in a minute, there you go. So copy that joint with that plate. I'll put it on this leg, so it's that beam, that leg, and let's put it in. Lovely. So that's coming on well. Now we can mirror those items to the other side. So I'm going to go to transform elements. I'm going to say I want to select the objects. The main bits I need to select are the 3 beams that I'm interested in. In fact, I don't need to select anything else manually. I can just select those 3 beams. And then I say include additional connections. And by doing that, it automatically finds all the bolts and all the joints that go with those beams. And then I've got to remember to make sure I say it's mirror. And because it's 3D, I prefer to use the 3D version of mirror. My mirror plane, I've got select points on that, so it's mirror. And it'll be endpoint on the diagonal line there, endpoint on the diagonal line top, and let's go for the end point of the horizontal line at the bottom. So I think I've set that up right. I can click on the preview button, and it does the mirror. Yeah, that's all looking good. So I can, hang on, it's asking me to confirm something. Oh, where's that beam? So I can say I want to do that one. These are going through the same members. Being a bit touchy there. There you go, got the mirror done. So now I can say I'm happy with all that, I've had a look at it, so I can just say OK. The only thing that hasn't gone right, because we offset this base plate, it's gone the wrong direction. So we need to go into the joint for the base plate and make sure it goes the right direction. So probably just need to make that minus. Looks like the bolts did go the right way, so that's fine, it's just a plate you need to move. Anything that's handed goes left or right, above or below. They have a habit of going the wrong way whenever they get the chance, so you often have to flip them to the other side. It's not exactly difficult, is it? Lovely. Okay, let's hide all those joint boxes, they're getting a bit messy now. So I'll just go to them. Wonderful, that's clear. Now we've got most of the conveyor belt. Time to start making this platform at the top. So for that top platform, I have the construction lines here for the hopper, where I want to put that high enough so that it clears the truck, you're not going to bang into it, and therefore I need supporting legs around that sort of height, and I've got the legs spaced around the truck here. So I've just got some construction lines for where I need to put the legs, so I'm simply going to do beam from line. Those, and I'll just use an I-beam. There you go, and that should be in the centre line. So that's the main legs. Now I can draw that beams around the top to hold things up. So from the ends, I don't need one across there. Top middle. But I do want to put one either side of the hopper, so I'm just going to go from the middles. A little bit, let's grab that grip and move it to the proper middle. And then I need to move that up beam. Obviously, I don't want through the middle of the hopper, so I'm going to move that to one side. 700, and copy it to the other side. So that's going to support the hopper. Okay. So let's put some basic joints on them. Nothing particularly unusual about that. So base plates come first. Again, I want 400 by 20, so just pick that off the list, and it will be centered, so I don't need to adjust anything this time. It's fine. So I can do a multiple copy on that, and just pick the other 3 columns. Is that done? And now I want to put straightforward end plates on these beams around the tops. So single side end plate between that beam and that beam. It comes up with some default values, but I want to make sure I use something sensible. Now the entire BCSA Green Book is programmed into the UK build, so I can just look in here for the right beam size into the library, and that will be okay, a 254 depth of beam, which is what I'm using, 2-bolt version. So there you go, it's adjusted itself to suit the Green Book pre-calculated joint. And now I've got one of them, I can use joint copy to put the same thing on in lots of other places. So there, there. Just going around picking each pair of beams in turn. Like so. Splendid. And now we can draw the hopper. So the hopper is going to be made out of folded plate steel. So we've got the shape we want for the top and the bottom of the hopper. These are just 2 polylines. We have a very simple command for doing the hopper, create conical folded plate. Tell it I want to pick a contour at the top, which would be that line. And I want a contour at the bottom, which is that line. And then it says how many facets do you want in each corner. And I'll go for it. There you go, just like that, it's created the whole hopper. But that hopper is not going to float. I need to put some flanges on there to bolt these bits of I-beam. So I can simply say I want to put in a rectangular plate, and I'm going to put it on the midpoint of this edge. Must have fumbled. Let's try that again. I'll put my UCS at the top would be a good move, because that's where I want the plate at the top, not on the ground. Try that again on the midpoint of that edge. There we go, there's a plate. Give it the right dimension, so it needs to be 100 that way, and that'll be 800. And that should be on one side. The other side is going to be, no, that one. There you go. So that's offset it to the right side. So now we do the same for the other side. And that'll have to be offset that way. There you go, that looks good. Marvellous. So I've got them on there. Before I make them into part of the hopper, I want to put the bolts in. And I don't want the bolts to be confused with other dimensions, so I'll put the bolts in now. I want to put the bolts in the middle of the overlapping area. So it's not going to be 50, because that's not going to be in the middle of the flange. I want it in the middle of the overlapping area. So there's a tool we can use for that on the custom connections page. These little tools here are nicknamed building blocks, and they will give you a little tiny bit of intelligence. So here's bolts on a plate. So I'm going to choose that plate as my main plate, and then I want to bolt it to that beam. I'll just tell it here I want 5 bolts in the X direction. No, other way. So 1 bolt in the X direction, 5 bolts in the Y direction with 200 spacing. Okay, let's reduce that to more like 150 spacing. That looks good. And it tells you here, look, it's based on the intersecting area. So the area where they're overlapping is what we're going to get. Let's go for 160. Looks better. Okay, that's done. I'll do the same on this set. So it's between that plate and that beam. And again, it's 1 in the X, 5 in the Y, 160 spacing. Lovely. Now I've got them bolted on, I can now merge those plates into the hopper. So to do that, I want to create a fold. They're already in the right position, so it's create folded plate without position adjustment. It's that panel and that panel I want to fold together. You see how it's put a fold now across that edge. And I'll do the same again here. So it's this panel and this panel. Fumbled, try that again. This panel and this panel, there you go. Put the fold in there to connect them together. So that hopper is now one piece. I can even have a look at the flat pattern if I want to. If I go to properties and ask it to show me the flat pattern, there you go. There's the flat pattern with the flanges all included. So that's the hopper complete. Now the top of this conveyor needs a bit more supporting, so let's go ahead and do that. I need to put a leg, or I want to put a leg on top of this beam here. So I have to figure out how to do that, how to get the right height and so on. Well, there's various ways I can do that. What I'm going to do, I'm just going to draw a simple, straightforward bit of channel. I'm going to can't snap to the right distance across or the right point. So the nearest snap point I've got, I'm going to use the end of this beam here. I'm just going to go up a short way. I don't know exactly how high it's got to be. So I'm just going to go up a short way. So 200 seems plenty. Get the orientation and everything sorted out. So let's rotate it and put it on the middle. And that was going to be -50, wasn't it? There we go. Now it's got that in the right place, but it's got to go across there, not on the end of the beam. So now I can just do an ordinary move command, and I want to move that beam, and I want to move it from where it is, the centre line there, to the centre line of that. I don't want to move in any other direction. I don't have a snap point in the exact location, but again I can use those point filters. So this time I'm going in the Y direction, to be dot y to the node on the end of that beam, and it's moved it across to match the centre line. Fantastic. So I've got that joint or that beam in there. Now I just need to add in the connections. So I've already got one connection from down here, so I can just copy that. So I'll copy that connection between that beam and that beam. Splendid. Then to the bottom of it, I'm going to need to be some kind of end plate, I think. So I'll just do again a single side end plate between that beam and that beam. All looks a bit weird, but I just need to knock it into shape. So I'm going to say I want to base the size of the plate on projection, and I want 0 projection all around, so it matches the spacing of the channel. The same vertically, so it's going to be plates based on the section. I'm going to put it in the middle. I'm going to have that as be the total from the middle. And it should be 300 because it was a 300 channel. Now the plate matches the channel. The bulk spacing doesn't look very good. That's a bit too wide, so I'm going to change that bulk spacing to, let's say, 80. That looks better to me. And there we go. That'll do for a joint there. It's bolted firmly to the top of that cross beam. Okay, so we need to do one more supporting beam. I want another beam underneath the sloping conveyor bolted to these columns. That's going to be a bit tricky to place and get it at the right angle and all the rest of it. So the first thing to do to get it at the right angle is to get my UCS on the slope. So I can just place UCS object onto that beam, and that's got it at the right angle. The nearest place I can draw the beam will be the top of these columns. So I'll go for an I-beam across the top of the columns. That should be top middle. Okay, so that's got it roughly there. Now I've got to get it down to the right height. That's going to be a little bit more tricky. So what I'm going to do, I'm going to hide everything except these 3 members. So it's those 3 members I want to see, and I can tell it here to show me only those 3 members. Then I'm going to go to wireframe, and I'm going to go to the front view. Okay, so I want to move it vertically, so I need to have one of my axes vertical. So let's just change back to UCS on world. And now I can do a move that beam from the top of the column. I want to move it down to where it looks like they're going to intersect here. But I only want to move it in the Z direction, not any other directions, in case that gets confusing. So I'm going to say dot Z, so it's only going in the Z direction. Then I want the apparent intersection, because they don't really intersect those lines, they just look like they do from this direction. So it's the apparent intersection of that edge and the centre line there. That's moved it down. So that's marvellous. Got it the right height. Sticking out there, which isn't great, so I probably need to move it left a bit. Now that needs to be moved on the slope. So once again, I'm going to do UCS object back onto that sloping beam. And then I'll just do a move that beam. And you can see on my cursor it's telling me how much I'm moving it. So if I just move it with auto turned on, 50, it says I'm going 48 there, that looks about right. So let's make it 50. And that's put it in a sensible position, touching the bottom of that sloping beam. Marvellous. So now I can go back and turn everything back on. So go back to realistic. And the easiest way to turn everything on without turning on all the rubbish is to use the Project Explorer to show all elements. Like that. So now that beam is in the right position there. So I can come in here, and I just want to bolt those 2 beams together, and a good joint for that is on the miscellaneous page called bolt on gauge lines. So I can simply use that, and I'll do that beam to that beam, and it puts 4 bolts in, or 2 bolts in the middle of the flange on each one. And I'll do the same on this side, bolt on gauge lines, that beam, smashing. Now to get that angled or rotated beam onto the column, I'm going to go for the platform beams page, and there's various choices in here, but one that's good for this one is, let's so I can see the pictures. That one. 2 end plates reference beam. So you can see how on the left hand picture it's got kind of the arrangement we're looking at. So I pick that, so that column, that cross beam, let's put it in there. Now the bolts are right on the corners, I need to get them in the right places. So if I go to bolt 1, that's going to be something like 50. Yep, that looks good. And say 30 that way, that looks reasonable. You can obviously play with these numbers as you wish, but I'll take those. So I do that on all 4 corners. Like so, and that's a decent looking joint. Nice end plate on that beam. So I've got one set up. Make that box a bit smaller now. Close that down actually for now. And I can do a joint copy again to get the same configuration on this side. There you go. So there's joints in there for pretty much every occasion. You just got to find what you need. Sometimes you have to experiment a little bit, but that's got pretty much everything in there with all the joints. Super. Nearly done. Got all the hard work done. Now I'm just going to make a bit more of this platform. In fact, before I make the platform, let's do the conveyor belt. Be nice to show some kind of conveyor belt in there. So what I'm going to do, I've got some construction lines already drawn. To make the conveyor belt, I'm going to use a combination of folded plates and folded beams. And I would need construction lines to show me the shapes I want. So I've drawn a construction line, you can just see it in red there, down the top of the rollers and across there and up this side and across the top of this roller and so on. So what I'm going to do, I'm going to hide the layer for the beams, hide the layer for the special parts and everything else. Let's just turn them all off. So special parts turned off. And the other construction lines can go off as well. I just want the construction lines for belt I want that turned on. I can turn off the bolts while I'm here. Let's just keep the display clear. There you go, that's nicer. And what I'm going to do, I'm actually going to put myself on the layer for concrete, because we haven't got a layer for rubber belts, but the concrete kind of looks a bit like a rubber belt. So I'm going to go for the layer called concrete footings, and then I can turn the plates layer off as well. Let's hide those joint boxes. Okay, so now I've got a fairly clear screen. So you can see this line I've drawn. You said I drew down the roller, across and up. I've got another one there, and around and up. Now I can't use those lines because they're part of the blocks. So I've drawn new lines on top of the blocks. These ones are just lines. That's just a line, that's a polyline, and that's an arc. So like I said, I'm going to use a combination of these things. First thing I'm going to do is draw the bit wrapping around the roller at the top. I'm going to use a folded beam for that. Let's go back to, that's fine, folded beam, and it's an arc I'm going to choose. So it's that arc, center of the system line, my reference point, I'm going to do the end of that line, and then I'm going to draw it actually going from the end of that line to the other end of that line. And there you go. I only want that 5 thick for the belt. Let's say the material should be other. Do we have rubber in the list? There you go, rubber. Now, so that it doesn't get in the way when I'm trying to choose other things, I'm just going to hide that. And then I'm going to do the next segment. So to go from that straight edge on top of that roller to the trough shape on the other rollers, I need a twisted folded plate. Here we go. That's going to be simply from that line to that line, and I want it 5 thick. There you go, just like that. Again, I'm going to hide that so it doesn't make it difficult to pick the next bit. I want another twisted folded plate, which is going to go from that top roller down to the bottom roller. thick. Like that. I'm going to do the third one for the transition down the bottom. And do another bit of folded beam to get the curved bit. So again, that's based on an arc. It's that arc, and the reference point is the end of that line. And now I'm going to go from the end of that line to the other end. That line, that's 5 thick by materials rubber, and select that, hide that. The last one I want to do is going to be a simple straight bit going up the other way. So that's easy, I can just do that as a rectangular plate 2 points from the end point of the roller there to the end point of the roller here. Let's not put it at the right height, make sure it's 5mm again. Change the rubber again. I know it's not at the right height, so I just need to move it to the right height. So simply do a move that part from the top there to the end point on that construction line there. Right, so if I turn all those back on, just use the Project Explorer, bring everything back, all layers on. There we go, you can see I've got that rubber. It's not perfect, I know, but it gives you a nice representation of that conveyor belt wrapped around those rollers. Now I want to do some bracings. So that conveyor, I think I need to put some bracing on that conveyor to strengthen it. So I've got my UCS already aligned with the conveyor. So all I need to do is go to the bracing macro, and I can go from the end of the system line there to the end of the system line there. And trouble is it's hiding it inside the rollers. So what I'll do, actually, I'll move it down and then we can see what we're doing. So I'm going to hide that layer with the conveyor belt. So let's put myself back on the standard layer. I just did that bracing on the wrong layer, so I'll do that bracing again in a moment. Let's hide that. So let's do that bracing again so it comes up on the right layer. So from that to the node there. There you go, you can see the bracing now in the middle. I want to change all that. So if I go to the geometry page, I can adjust that. I actually want 3 X's going up the length of the conveyor. I don't want them to be that chunky, so I can reduce the size of that angle. 60 by 5 would be plenty. That's got the rough geometry, but I don't want it on the top face. I need that in the middle of the conveyor. So all I need to do is do a move, and you see this white frame. This white frame controls that bracing, so I just need to move that down. I want to go underneath the belt. I'm going to go down in the Z direction 200. So there you go, let's move the bracing down now towards the bottom of there. It looks good at the bottom. Now how close is it getting at the top? A bit too close at the top there. So let's grab that frame and I'll move that edge down. Make sure I'm moving in the right direction. So move that down that way. I'm going to go down, let's say 300. Make sure it's clear of the roller. Looks nice at the bottom. I can live with it where it is on the bottom. So just double check the spacing, make sure these are all equal length. When you adjust the length, you have to tell it to update the spacing in the field. So I'll change that to 2 and then back to 3. And it recalculates where the midpoints are so that the spacing and all those bits of angle are the same length. Now I need to put a connection on that angle, and we have the suitable ones in the library already, so just go for bracings. It'll be gusset plate at one diagonal, so it'll be that channel to that angle. Looks a bit odd like that, don't want that long slender bit, but that's just because I need to adjust the setting. I'm going to change that to 2. Now that looks much more sensible. Happy with that? So I can say joint copy multiple. I have one of those, and I need to go for that beam and all these diagonals. There you go, let's put one on either end of every bit of diagonal. I would have actually put an extra one on the bottom here, I know that, so I'm just going to select and delete the duplicate one there. Fabulous. I want to do the same for the legs here, so I will simply adjust my UCS. And then I'll use that bracing macro again, from the bottom there to the top there. Now it's obviously going up through the conveyor, through the channel, because it's going right up to the system line. I don't want to do that, so I can tell it offset from the bottom would be 50, offset from the top maybe 500. So that moved it down a sensible amount to there. It's fine. Make sure I put it in as the right size of channel. Angle. Wonderful. Now I can use the same joint I've already got. So I have one of those. Let's do a multiple, one of those, and I'll have it on those channels and those 2 bits of angle. That's the 4 corners taken care of. To give it the full strength, I need to bolt those bits of angle together. So at the bottom of that page you have direct bolt between those 2 sections, and just need to set these distances to half the flange. There you go, the bolts in the middle holding those 2 bits of angle together. I want to do the same on these other legs, so I can move my UCS to those legs, and then I can say I want all the same parameters, so I'll just use joint copy. Don't go all the way up because it will go through the beam, so I'm just going to go to the end point of that beam, will be fine. That's taking it to there. Marvellous, that looks good. Then I can do a joint copy multiple for the gusset plate. Super. And then I'll do a joint copy for that direct bolt. And that's done. So that's the bracings done on 2 sets of legs. There's all the bracing I need now. Let's put the layer back on. Bracings underneath the conveyor belt now. Looking nice. So now the last things I need to do are finish off the platform at the top. So let's clear the screen a bit. Now I can simply put a bit of grating on the top here, so I'll just go for a bit of rectangular grating. Put my UCS in the right place first. Put my bit of grating on, like so. I could bolt it down, could do other things, but I won't bother with that today. Plenty of other presentations showing you that. I want to put a cage ladder going up this centre line. So make sure my UCS is pointing in the right direction. It's important you get that in the right direction to get the cage on the right side. And I'll ask for a cage ladder from the end point at the bottom of that construction line to the top of that construction line. If it's a ladder in, it's not the right ladder yet. There are lots and lots of things we can play with in here about everything to do with the ladder, the shape of the cage, the spacing of the rungs and everything else. You can store your favourite settings in the library. So rather than watch me play with umpteen different parameters, I've already stored what I want in the library. So just select it from the library, and after a little bit of thought, there's a lot of parts to remodel. There you go. It's created the ladder with the right dimensions. Now it doesn't do the exit cage very well, so what we need to do as a workaround is just draw another ladder nearby with all the right dimensions for the exit cage. So I'm just going to simply choose my exit cage library entry. Like so. And then we can copy those exit hoops onto the main ladder. So just literally use the copy from here. 1, 2, 3, from the end of that stringer to the end of that stringer. Lovely. Finish that. I need to make these bands go up to the top, so I can use the trim and extend, the advanced trim and extend. I want to go extend. I want to go to the face of the beam, and I'm going to go to this beam, and these are the ones I want to extend. That one, that one, that one, that one, and that one. Okay. That's extended them to the bottom, but I want it to go to the top, so if I select them again, I'll extend to the next face, which is the top face. Now they're all extended up to the top face. And I'm finished. So that ladder's all now one fabrication. Like so. So I can get rid of this dummy ladder over here. That's my ladder done. Last thing to do is put the railings on. So we have a macro for the railings. There you go. So I just need to go on this beam and this beam. I'll start at the end of the stringer there and go to the end of the beam there. Don't need to select a nosing point. Okay, that's a start. So let's just make a few simple alterations. I'll go for the I don't want a mitre in the corner, I want a curve, so I'll change that to a radius. And then on the end there, I need a bit of a loop so you don't hurt yourself on it. So I'll just change that to loop. I don't want it sticking out because that's going to close the gap down, so I'll make it no extra length. Then we need to bolt that to the I-beams. They're on the centre line at the moment, so we need to move it out. So I'll say I want to move it 50. There you go, that's now on the outer flange. And to connect it, I'll put plate with bolts. And I just want one line of bolts. Okay, now we could obviously adjust that further and mess about, but you get the idea. That's close enough. So we've got one, and I'm going to copy the same railing, same setup now. So it's joint copy, same railing to the other side. So it's that beam and that beam, starting here, ending there. No nosing point. That's lovely. It's just put it on the inside, so all I need to do is just edit that and move it the other way on the offset. So it'll be a -50 offset. That's back on the outside again. Close that. And there you go. Just hide all the rubbish. Turn off my construction layers. Move to raw coordinates. And there you have my conveyor belt, sloped conveyor belt, to carry the rubber up to the hopper. It's going to fall through that cone-shaped hopper or tapering hopper. Got an access platform with a bit of grating, cat ladder, and railings. So should you need to access the top there against the roll or do anything else. So I'll save that, and that's complete. Thank you very much. Okay, so we finished the model. And as you can see, Advanced Steel is capable of modelling pretty much anything you like. The modelling commands are versatile. You can apply them to whatever type of structure and supporting steelwork you need. You've got good plate tools and so on, and macros to automate many common arrangements. So the kind of things you might need in the materials handling industry, you can model your kind of structures, conveyor belts, platforms, access ways and so on, just as easily as it can model other buildings or fancy stairs and railings. So I said I wouldn't go into a lot about the output, but obviously the model itself is not the end goal. We need to produce some kind of output, drawings and so on, for manufacture. So obviously we can create all the output you would expect. We get full sets of drawings, part drawings, assembly drawings, general arrangement drawings, bills of materials, NC files, all automatically. I produced some from this model myself, preparing, so we can see how long it takes. To do that process, you need to assign model roles to the members in the model, number the whole model, produce the drawings, and maybe touch them up a little bit or just check a few things. And overall, that took me about 15 to 20 minutes to do that, straight off from nothing, wherever you've seen me there, to a full set of drawings and things. And that included this GA drawing. So you can see there I've got 3 main views, and I've got a close-up of the hopper. So you can have 3D views, orthographic views, whatever you wish. Some assembly drawings, so you can see I've got the railing on the top there, and at the bottom I've got one of the columns. So they're produced automatically. That's totally 100% automatic, nothing doctored, nothing edited on those drawings, just as it comes. You can get individual part drawings for any given part as well. So there's one of the supporting beams supporting up the rollers. You can get your bills of materials, so you get lots of different formats for bills of materials. That's just the standard material list there, just lists all the beams and plates. And the NC files to go with those for manufacturing with NC machinery. So you can get everything you need. And like I say, to do the full set took me about 15 minutes, give or take a little bit. There's plenty of other demonstrations that will show you how to do all that in more depth, of course, how that process works. The focus today was on how you could apply the modeling techniques to different types of structure. So with that, I've completed my content. Has anyone got any questions? If you have any questions, type them into the question panel on the GoToMeeting interface, and I will attempt to answer them. I'll give you a couple of minutes to see if you've got any. No, it doesn't look like there's anything coming up for questions then. So I hope everybody enjoyed watching that demonstration. Whether you do materials handling or not, there's plenty of tips in there and techniques that you could watch carefully how we did various things, and you could maybe pick up some ideas there you can apply to your own models. And if you haven't seen it applied for that kind of structure before, I hope you found that informative, so that you can see how it can be applied to any kind of industry, really. Okay, thanks for your attention. Thanks for watching. I hope you enjoyed it and found it interesting. That completes today's webinar. Goodbye.